My name is Joshua Chang, and I will be explaining linear equations. Right here, we have slope or rate of change. You can show the slope or rate of change by using a graph or a table. While using a graph, you could count the spaces in between the points. So as you can see, this point is at 0, 0 at the origin, and the second point is at 2, 1. Or no, 1, 2. Sorry. So it goes over 1 and up 2 from the origin. So the slope is 2 over 1 because it's rise over 1. The table shows the change in x and the change in y. So x is 0 here, and you add 1, it gets 1, and then y is 0 here, add 2, it gets 2. So 2 over 1. Pretty easy. So the formula is right here. y2 minus y1 over x2 minus x1. Okay, moving on. We'll be moving on to slope-intercept form. So we use slope-intercept form because it gives us a starting point of where to start. So when you have the y-intercept right here starts at 3, then you can have the equation y equals mx plus b, while b being the y-intercept. The y-intercept is important because it's the starting point of where x is 0 and y is a number. So y equals mx plus b, we find the slope in here, which is 2 over 1. So the equation is y equals 2x plus 3. If x equals 2, then we could get y equals 2 times 2 plus 3, which is y equals 7. And the point is 2, 7. Point slope form, right here. We use this. It's better to use if you have one point on a line and you find the slope. So, right here, the equation, y minus y1 equals m times x minus x1. x1 and y1 are the known points that we know. M is the slope, and x and y are any points on the line. So, on this graph here, we have 2 points, 3, 9, and 1, 3. If we take the slope equation and use it to find the slope, we get 9 minus 3 over 3 minus 1. So we get 6 over 2, divide that, we get 3 over 1. So the slope is 3. We take this, we put all the numbers in the equation, so y minus 3, because that's where y1 came from, equals 3, the slope, times x, which is basically any number on the line, minus 1, because that was the number from x1. So basically, it tells you the point, which is 1, 3, and it gives you the slope, 3. Moving on. We'll be moving on to standard form. Standard form shows the y and x intercept. So it's basically ax plus by equals c. However, it's really important that you can't have ax be a negative, or there can't be any fractions or decimals in your equation. So demonstrating this, we have 4x plus 3y equals 12. If y was 0, it would be 4x equals 12. And if you do that, you get x equals 3. Or if x is 0, you can find the y-intercept. 3y equals 12. You get 3y divided by 3. And 12 divided by 3, you get y equals 4. Once you graph that, you take both intercepts. Really easy. You put the x-intercept, which is 3, y-intercept, which is 4, and you get your line. Right here. Just explain the x-intercept right here. Really easy. Just if y is 0, then that's your x-intercept. For horizontal and vertical lines, we have right here, we have a horizontal line, and it's 0 over 2 because when you have nothing rising up, it just stays in one place. So if this point was 2, this is just a number on the line, it doesn't matter. It goes across without going up or down because it has no rise or y. When we move on to vertical lines, it's 2 over 0, or it's undefined, because it goes up but doesn't have anywhere to go right or left. Okay, so now if I were to pick between two methods, right here, point slope in standard form, I pick point slope because it gives you the point, which is 1, 3, and it also gives you the slope. If you get this, it's really complicated, or makes it harder because you can't have any fractions or decimals, and the AX can never be negative, so it makes things harder. Also, it doesn't give you the slope, so not good. So that was my video on graphing linear equations. Yeah.